All right, we're starting lesson 10.2 today on multiplying polynomials by monomials. This concept is one that we've really discussed and worked on already. We're going to apply it to a little bit more complex situation today. And by complex, I just mean that the polynomial is going to have more than a couple of terms in it. We're also going to solve equations today that involve this concept. Let's jump into it here. So we're going to be multiplying a polynomial by a monomial. So remember, a polynomial is it could be a monomial, binomial, trinomial, or it could have 4 or more terms in it. Okay, but remember these terms are well, I should say a polynomial is made up of monomial terms, and those terms are numbers, variables, or products of numbers and variables, and they're added or subtracted together. And we're going to multiply those by a monomial, which is a single term. Okay, essentially what we're doing here is using the distributive property. We're just going to use the distributive property, simplify our result each term as we multiply it through, and then we're going to need to make sure that we have it written in standard form. Okay, so that's really going to be our process. So the title is multiplying a polynomial by a monomial, but in essence what we're doing is using the distributive property. Okay, so this is our monomial, 2w squared. And we're going to multiply our monomial by this polynomial, which has 3 terms in it. 8w squared, negative 4w, negative 9. So this is the polynomial times a monomial. It is really just distributive property. So let's take a look at it. So we're going to take our 2w squared and multiply it by the first term. Okay, so that's 2w squared times 8w squared. We're going to take our 2w squared and multiply by the next term, which is negative 4w. So I'm just going to put a minus 2w squared times 4w. Okay, the 2 is positive, the 4 is really negative. It's going to be a negative answer, so I just put a negative sign in front of that. And then lastly, we're going to take our 2w squared times our 9. So that's going to be minus 2w squared times 9. Okay, so we take our outside monomial term and multiply by each of the interior terms. And now we simplify each of these separately. So this first product here, 2w squared times 8w squared, if you remember what we did with this is a monomial times a monomial, is because all of this is multiplied together. It's 2 times w squared times 8 times w squared. Then we can reorganize that. And I'm going to make it 2 times 8 times w squared times w squared. Same 4 factors, just rearranged. So I get the ones that are similar to each other, next to each other, to simplify. The second piece here is 2w squared times 4w. Again, I have 4 factors, the 2, the w squared, the 4, the w. This is all multiplied together. So I can reorder that using the commutative property. And I'm going to make it 2 times 4 times w squared times w. And then I'm going to do the same thing here at the end. It's 2w squared times 9. Remember, this is really like 2 times w squared times 9. So I can reorganize this. And I'm going to make it minus 2 times 9 times w squared. Okay, so that's how we simplify these. So we kind of rewrite them. And now we're actually going to write that out. So this first one, this first term, again, this is a product of numbers and variables. So it's a term. This first term, 2 times 8 is 16. And then when I take a w squared times w squared, the rule is add the exponents. So that's going to be 16w to the 4th minus 2 times 4 is 8. This is w squared times w to the 1st. So I'm going to add those together and get minus 8w to the 3rd. And then the last piece of this is 2 times 9 times w squared. That's going to be minus 18w squared. And there's our simplified answer. It's in standard form. Remember, we go by degree. So degree of 4, degree of 3, degree of 2. So I'm going down in size. Okay, signs are important. So I make sure I get all my signs correct, but that's how we do that. Okay, let's look at another one. It's a little bit more complicated. And the only reason it's more complicated is because I added another term in here, but it's a monomial, negative 5u cubed, times this polynomial, which has 4 terms. The first term is negative 9u cubed. The second term is 4u squared, then 6u, and then negative 4. So we have to distribute this monomial term through this polynomial. So I'm going to start out by taking my negative 5u cubed times negative 9u cubed, first part of it, plus. Now I'm going to take my negative 5u cubed times 4u squared, negative 5u cubed times 4u squared. Then we'll take our negative 5u cubed and multiply it by 6u. And finally, take our negative 5u cubed and multiply it by negative 4. Okay, so you can see the 4 different products that we have to simplify. There's my first product, my second product, my third product, and my fourth. Okay, so looking here at this first one, again, this is a product of 2 monomials. I'm going to get a monomial answer. These are, this is really negative 5 times u cubed times negative 9 times u squared. So I'm going to reorder this. Okay, and I'm going to make it negative 5 times negative 9 times u cubed times u cubed. That should have been a u cubed. That's just I miscopied that. Okay, that should have been a u cubed. So that's why it's u cubed here. Okay, and then I'll do the same thing here. This is a product right here. So there's 4 different factors. 5 times 4, u cubed times u squared. The next product is right here. Okay, I'm going to reorganize that to negative 5 times 6 times u cubed times u. And then finally, my last product, I only have a variable term, one variable term here, but I have the 2 numbers. So I'm going to make it negative 5 times negative 4 times u cubed. Now, you may not do all this when you're doing these problems. I'm doing it to show you exactly how this works. Okay, but let's go back and finish this up. So this first term, this is my first monomial term, negative 5 times negative 9, positive 45, excuse me. And then when you multiply powers with like bases, you add exponents. So this is going to be positive 45u to the 6th. Here we got, really, it's a negative 5 times positive 4. So that's going to be a negative 20. So we're going to get a minus 20. And then u to the 3rd, u to the 2nd, add those. We get negative 20u to the 5th. The next term is right here, this product. It's negative 5 times 6, negative 30, u cubed. That's really a u to the 1st, so add exponents, negative 30u to the 4th. And then finally, the last term is negative 5 times negative 4. That's positive 20 times u cubed, positive 20u cubed. So there's a simplified version of that. It's called multiplying a polynomial by a monomial, but it is in essence just the distributive property, working our processes and simplifying. Okay. The other part of this is to add some equation solving. So we're going to solve equations today, and they're going to involve these polynomial expressions that we have to distribute, simplify, to be able to get to our solution. Okay, so our process is going to be this. The first thing we're going to do is look at the left side of the equation, which is everything to the left of the equal sign. We're going to look at the right side of the equation, which is everything to the right of the equal sign. And we're going to make sure that each side is simplified. That is, we've distributed through any parentheses necessary, and we've combined all like terms. Okay, by doing that, we're going to break our equation into terms, and then we can work with those terms to get the solution. The second step is always to isolate the variable term. That means, the variable term is generally going to be a product of a number and the variable we're trying to solve for. So it's going to be a number times a variable. We want to isolate that. We want to get that on one side of the equation by itself. Typically, what we have to do is subtract or add a number to both sides to eliminate the number on the same side as that variable term. Now, sometimes there's an extra step here, and if there ever is a situation where we have a variable term on each side of the equal sign, then the first thing we have to do is eliminate one of those, which means subtract or add to make it a 0. And then we go to this step and isolate the remaining variable term. The last thing we do is actually isolate the variable itself. Now, what that means by isolate the variable itself is to peel that number off that's being multiplied, or actually it's like its coefficient. We want to make that become a 1. And what we typically do here is either multiply or divide by that coefficient. So if it was 2x, we would divide each side by 2. If it was x over 4, we'd multiply both sides by 4. So that's that step. We're trying to make the number in front of that x or that variable become a 1. Now, we've talked about this. If the coefficient is a fraction like 2/3 times x, and we're trying to isolate x, we're going to multiply by the reciprocal in that case. Don't divide each side by 2/3. Multiply each side by 3/2. Okay, so there's that little wrinkle right there when we go to solve these. So in essence, we're going to continue to work on our equation solving process. This should be nothing new to you, but we're going to have a little bit more distributive, combining like terms, concepts involved in it. Let's take a look at one. So this is a pretty basic equation. 3 times the quantity of 4x plus 9 equals 63. In our new terminology, this is really a monomial times a polynomial, or in this case, a binomial. So what we're saying is, if you look at your steps, the first thing we want to do is simplify each side of the equation. So there's a distributed process here, so we need to do that. So let's go ahead and distribute 3 times 4x, and then 3 times the 9, and then we still got 63 on the right side. The right side of the equation, you can't simplify that anymore. It's a single term, and it's 63. The left side now, we've broken into two different terms. Okay, we did have a product of two terms. Now we just have two terms. Let's simplify each of those. Obviously, 3 times 4x is 12x, and 3 times 9 is 27. So now I have it simplified. The left side of the equation is simplified down to two terms. They're not like terms, so I can't put them together. The right side has always been a single term. So now it's time to solve for x. So I want to get, first step is to get the variable term. So this is the term that has the variable in it. I want to get that isolated. So I want to make this a 0. How do you make 27 become 0? Subtract 27. Whatever you do to the left side, do to the right side. Okay, that keeps balance in your equation. So as a result of this step, we're going to have 12x equals 36. Now, we don't want to know what 12 times x equals. We want to know what x equals. So this is what we call the coefficient of the variable. I want to make that become a 1. How do you make 12 become 1? Divide it by 12. So 12x divided by 12 will let me cancel those 12s and give me x, and then 36 divided by 12 is 3. So the answer to this problem is x equals 3. Okay, let's look at another one. This one's a little bit more complicated because we have two variable terms, and this variable term is in a grouping symbol. Okay, so the first step in our process is to simplify the left and the right side of the equation. We got some work to do on the left side. Okay, first of all, we have this distributed property problem. That takes precedence because that's a multiplication over addition deal. All right, so the first thing we're going to need to do, that negative 5w I'll bring down, and now I'm going to work on this. So I'm going to go through my distributed process, 2 times w and 2 times 4, and that equals 38. We got this set up now. So now I have, three terms on the left side, a negative 5w, a 2 times w, and a 2 times 4 term. So if I simplify all those, it looks like this. So three terms, negative 5w, 2w, 8 equals 38. The next thing we always want to be sure to do is to simplify by combining like terms. So on the left side of the equation, I got these two like terms. We want to put those together before we start solving. So that'll give us negative 5w and 2w is negative 3w plus 8 equals 38. Now we want to isolate this w term. So we want to make 8 a 0. So we will subtract 8. And now it's negative 3 times w equals 30. I want that negative 3 to become a 1. To make that negative 3 become a 1, we're going to divide by negative 3. That lets us cancel right there. And our answer is w equals negative 10. Okay. One last example, and all that happened here is we flip sides. We put our work on the right side, if you will. The process I got to really work with is on the right side. The number isolated is on the left. It doesn't make a difference. We could flip it right now if we wanted to and make it look like the others that we've just done. I'm just going to solve it as is. So if you look at the right side of the equation, we have a distributed property process. We need to do that first. All right, so the 3 on the left side stays as is. The negative 7g is going to stay here as this term. And now I'm going to distribute here. So 5 times g, 5 times 3. Okay, now if we simplify what we just did, we will get this equation. So negative 7g plus 5 times g plus 5 times 3. So we now look like this. So on the left side, I have one term. On the right side, we have three terms. Okay, of my three terms, these two are like. So let's put them together now. So negative 7g and 5g is negative 2g. The 15's, as is, the 3 is still over there. Okay, next step, isolate the variable term. That's the variable term. I want to get it by itself, so I'm going to eliminate the 15 by subtracting it. I want to make it a 0. So subtract 15 from both sides of the equation. So negative 15, or excuse me, 15 minus 15, 0, gone. 3 minus 15, negative 12. So we got negative 12 equals negative 2g. Now I want to make that negative 2 become a positive 1. Divide each side by negative 2. Going to get g, or 6 equals g, which we always think of as left to right, g equals 6. And that one is now solved. Okay, so those are the kinds of problems you're going to work on today. Distributive property, and then use the distributive property to actually solve an equation. Pretty straightforward, not a ton of homework problems to do, but I will let you get started.